Greetings, fellow muckers. Today, we'll be looking at a classical model problem. The problem. Part A. If money supply M is fixed at 400 and velocity V is fixed at 20, then draw the classical aggregate demand curve. Part B. If full employment is fixed at 1,000, draw the classical aggregate supply curve. Part C. If M increases to 800, how would the classical aggregate demand change? For parts A, B, C, draw one graph. Now take a few minutes and solve this problem. Welcome back. Hopefully you were able to solve this problem. Now let's work on it together. So, for part A, we're given that the money supply is fixed at 400. So M is 400. V is fixed at 20. And we need to draw the aggregate demand curve. So since we're on the classical model, we are under the assumptions of the quantity theory. The quantity theory of the classical model is money supply times velocity of money is equal to the price times the output. This is the quantity theory. And this is how you determine aggregate demand in the classical model. Quantity theory. So, if we plug in M and V, we'll get 400 times 20 is equal to P times Y. 400 times 20 is 8,000. This is equal to P times Y. Now, we need to draw this on a graph. So, let's draw a graph. So on the x-axis, we'll have our output of y, and on our y-axis, we'll have price. So we need to draw the aggregate demand. So at a output of 1, say 1's here, we'll have a price of 8,000. We'll say 8,000 is here. We'll put a point. And then our next spot, we'll have a price of 1 down here and an output of 8,000. Let's say right here. We'll draw a line that, and that's our aggregate demand for part A. So that is the graph, the aggregate demand for part A. Now for part B, if full employment is fixed at 1,000, draw the classic aggregate supply curve. So it's fixed at 1,000 supply. So let's just say 1,000 is right here. And it's just a vertical line. And this is our aggregate supply. And this is our equilibrium point. And our equilibrium point, so now we know output's 1,000. To solve that, we just get 8,000. So it crosses our for part A equation for quantity theory. 8,000 is equal to P times 1,000. So P is equal to 8. So this point right here is 8. So equilibrium point will be equilibrium point for part A is 8, 1000. And then now it says for part C, if M increases to 800, how will the classical aggregate demand change? Well, our money supply increases, so M is equal to 800, and our velocity is still the same at 20, so it'll be 800 times 20 is equal to P times Y. Then this gives us a value of 16,000 is equal to P times Y. If we draw this on the graph, same thing. So now 16,000, plug a 0.41, and 16,000 over here. Plug a 0.41. We'll draw this demand curve. This is our aggregate demand of 1, so this is a new one. And we got a new equilibrium point. So new equilibrium point will be 1000. It's right here, 16. So equilibrium new. And what happened to equilibrium with the money supply increases? Or the demand shifts up. Our output stays the same, but the price increases when money supply increases, and everything else is held constant. And that is the graph, and these are the solutions to the problem. I hope this video helped. If it did, please consider subscribing and like